All right, now we're going to look at part C of that 2006 Mechanics 3 question. So now I have my ring, and it's rolled down that ramp. We figured out how fast it's going to be moving at the bottom of the ramp, and now it's going to horizontally launch off that tabletop and land some distance away. So we have a horizontal launch problem, meaning my initial vertical velocity is 0. We have a projectile motion telling me my acceleration in the x direction is 0 because there's no air resistance, and in the y direction is negative g. So now we're going to go ahead and set that up. So when we set up projectile motion, we're going to set up our x variables, and whenever the acceleration is 0, the initial and final velocities are the same, and that's that g sine theta we got in part B. And then we're going to do the y direction. It starts at some height h, that's provided for us in the problem, and ends at some height 0. Initially, it's moving at 0 meters per second in the y direction because it's a horizontal launch. Acceleration is negative g. Now, we do want to solve for x. So whenever our acceleration is 0, we're going to be using that third equation. So we're left with x equals x naught plus v naught xt plus 1/2 axt squared. And we'll get rid of some of this because it's 0. And so now I have, the square root of gl sine theta times time. But I don't know how long it's going to take to go from here to here. But I will find time in terms of this height. Okay, so looking over here, we don't know the final velocity in the y direction, so we're going to pick equation number 3 again. So I have y equals y naught plus v naught yt plus 1/2 ayt squared. Go ahead and cross anything out that's 0, so it ends at 0. There's no initial velocity. And we can solve for t. And we can also kind of solve this. So we got t is equal to, so we're going to move this y naught over. So we have negative y naught times 2 divided by ay square root. Now if we plug in our variables here, this is actually the square root of 2 times the height. And the negative sign is going to cross out with the negative sign on the g. And so there's our time. We can bring that over, plug it in here, and so I have x is equal to the square root of gl sine theta times another square root, so I'll just put it all under the same one, divided by g. You'll see my, oh my goodness, you'll see my g's cancel out, and then we're going to go ahead and just plug that all in and find out that x is equal to the square root of 2h times L times the sine of theta. Okay? And that is in terms of the variables that are allowed. Now, part D wants to know, well, what if we use a disk instead of a ring? Is it going to land further? Is it going to land shorter? Is it not going to make a difference at all? And so what you have to think about is a disk and a ring have different moments of inertia. So that disk has a smaller moment of inertia, meaning it's easier to get rolling. Okay, there's less resistance to motion. And so that means there's going to be less rotational kinetic energy and more linear kinetic energy. So it's going to be moving faster at the bottom. You can think about the disc and hoop race we did down the incline, and the disc easily won, had a higher velocity at the bottom. So a higher velocity because of a lower moment of inertia for the disc provides a longer distance that it'll land from the table. And there's part D.